Okay.
All right. Hi, everyone. It is our great honor and pleasure to open this keynote session with one of our best keynote speakers here, Greg Lynn. It's an honor to have you with us. Thank you for accepting this invitation. Tigrati this year is its 25th anniversary. So for us, it's a very, very important occasion. We have our communities distributed across Latin America, Ibero-America, and also across the world. So this year we expanded the community to include every single country. So we're very proud of that diversity and the energy that is flowing through this network. I leave Dr. Marcelo Bernal here with us to introduce you and moderate this session. He got his computational design PhD at Georgia Tech, and now he's director of the Perkins and Will Design Process Lab Research.
Thank you, Paula. Again, for me, it's an honor to introduce today our guest speaker, Greg Lynn. He's the founder and owner of Greg Lynn Form, well-known firm, and co-founder and CEO of the robotic company Pleo Fast Forward. In 1986, he graduated from Miami University of Ohio with Bachelor of Environmental Design and Bachelor of Philosophy degree. In 1998, he graduated from Princeton University with a Master of Architecture degree. He won the Golden Lion at the Venice Biennale of Architecture. His architectural work is in the permanent collection of museums, including CCA, San Francisco MoMA, ICA, Chicago, and MoMA. And his Alessi Supple Mocha Cup and his Vitra Ravioli chair have been inducted into the Museum of Modern Art's permanent collection. He received the American Academy of Arts and Letters Architecture Award, is the recipient of the Red Dot Best of the Best Design Award, and was awarded a fellowship from United States Artists. He is professor at the University of Applied Arts in Vienna and UCLA, member of the board of trustees of the Canadian Center of Architecture, and author of 13 books. Personally, False Body and Blobs is my favorite. Welcome, Greg Lynn. It's an honor. Please, the stage is all yours.
Thank you so much for such a kind introduction. It's really nice to be here. So I will share my screen here. Let me know, are you seeing the full screen correctly?
Yes.
Yes.
Okay, great. Okay, well, so I brought, because I am assuming that there's a very wide spectrum of designers here at the event, that I would try to be as broad as I possibly can with some examples. So I'll go through, for me, what I would use Colin Rowe's distinction. He wrote an essay, The Literal and Phenomenal Transparency in Architecture. And I thought I would talk a little bit about literal and phenomenal motion of materials. And it won't only be limited to architecture. And what I mean there is that digital technologies, I started with as a designer, primarily in a phenomenal way, meaning that I was using animation software and various forms of motion as a sketching and modeling tool. I have dabbled a little bit in things that literally move. And for me, that was a big jump, but it also, there were a whole series of small steps that led to it. So I thought I would just kind of talk through that whole trajectory from using motion technologies that were digital as primarily design tools, to then using them to actually move things in the real world at a variety of scales. And you know, we have some time for some questions at the end, and I would hope that this isn't absolutely obvious. So I'm sure people will have some questions. But first, you know, this is an example of the Korean Presbyterian Church of New York that I designed along with Michael McInturf and Doug Garofalo. And it, for us, was one of the first uses of animation tools for design. And as you can see here on the exterior stair, where there are these 6 enclosures, each one a member of the same family, but each one unique in its size, shape, and the components used to construct it. And throughout the whole building, we used animation tools, which were working with repetitive elements, but every one of those elements was different in a sequential pattern. And for me, this gives the space and the building, even the exterior of the building, a dynamism where your eye moves from one element to the other in a moving, flowing way. This is not a new idea. It's you know, what Wolflin characterized Baroque architecture as being. Any number of people have characterized Baroque architecture as having visual dynamism because of the movement and repetition of forms in space. So for roughly a decade, this is what I was interested in. What I have to say is curious is that other architects and historians and theorists and critics, journalists would see the animations that were produced in the process of design and ask why the architecture didn't literally move. And I was always very defensive about that and said that architecture shouldn't move and architecture should have movement built into its form. And that's what made architecture different than industry, for example, or robotics. And I'll come back to that a little bit later. I would say the most extreme versions of this kind of encapsulated motion were in some furniture and fountains that I designed using recycled toys. So this is the duck table that's made out of a dozen or so duck toys. They're little sleds that little children would ride on down snow. And each one of these ducks was arrayed in along an animated path. So the way they were composed was not by just moving them in space, it was by animating them along paths and then freezing their motion as they moved. Also, each one of these was intersected with another, and those shared curves of intersection were then used to cut each one of them with a CNC, with a computer numerically controlled robot, so that they would fit together. And then it was a very manual exercise of assembling all of these parts one by one. So in here, you see on the right, and I've never compared myself to Bernini before, but I pulled this out this morning to make the point. My late father-in-law and my mother-in-law are both art historians. And Irving Lavin, my late father-in-law, was a particular expert on Bernini. And when I showed him the tables and the furniture that was designed, he said, oh, they have a spiral energy like Bernini's sculptures. And we ended up talking for a year or so all the time about the serpentine the twist, the movement of Bernini sculptures. So here on the right, you see either the seduction or the rape of Persephone by Bernini, where the composition is spiraling here in a counterclockwise way, so that the position and the arrangement of the two figures forms a virtual or phenomenal serpentine spiral that twists and moves up into space in a counterclockwise manner. And so there on the left, you see one of two fountains that I designed, also built out of these recycled toys, where the animation path for all of the bricks, the big plastic bricks, in this case was in a clockwise spiral fashion, but very similar to that serpentine composition. So again, I was using motion and animation tools to capture motion and animate your eye, or your perception as you move through space or move around, in this case, the fountain. And just here's a detail where you can see very literally that spiral pattern as these toys twist around in space and climb higher and higher. Again, all created by animating a scan of these along a spiraling path. So for me, I mean, I could show more examples, but for me, that was the way that I integrated digital animation technology or motion technology into architectural design. A lot of those tools I was using had a physics-based simulation component to them. So what I'll show here is computational fluid dynamics, which is a particle-based method of simulating the flow of fluids over surfaces, as well as finite element analysis, which tracks the path of loads, simulating material stresses on surfaces. So these are both used typically to optimize form. They're a design optimizing technique where you can simulate physics to make objects more efficient or higher performance. And so after, I started using with Wavefront, initially was the software I used, and it then merged with Alias to become Maya. But when I was using Wavefront, I was, experimenting, although that's probably the wrong word, learning some of these simulated physics tools. So especially the particle animation. So 15 or 20 years later, I decided to design and build a boat, which is a very high performance boat. I like to think it's also a beautiful boat. So I wanted to design an object, with a formal character of things that I was already exploring, but with a performance that put it on the edge of the available technology. So what you see here is a simulation we did. It was very much like going back to the 1990s, where we would set up forces and let the computer work, or actually a farm of computers work overnight, or sometimes even for a week or more, and then they would give us back results. So this is showing a trimaran that I designed with Fred Karubla, a trimaran moving through fluid, and those contours are showing the pressure in the water as it moves. And here you can see a coupled simulation of air and water, where the white streamlines are showing the forces of wind moving over the sails, which are creating simulated drive in the boat. And then you can see the boat in the water, and where you see the red areas, that's where there's a very high pressure of water as the boat moves through the water. And if you look at the curved line at the very bottom, that is a surface that's providing lift so that the boat slowly foils and lifts out of the water as it moves. But so this method of motion is a completely simulated environment, but it's where you can simulate force and form so that the force of the wind and the buoyancy of the surfaces is giving you a feedback that helps you refine the performance of the object. So this is an animation of one of those simulations. You know, in our simulation, there's nobody driving the boat. So almost every simulation ends in disaster of some form because nobody's correcting the boat as it moves. But it's telling us, in this case, where we should place the foil fore and aft on the boat, like where we want to produce that lift, and also where we want to position the sail and how much sail area we want to place fore and aft, so we know where the drive, where the forward force should be loaded. So this is then a little bit showing a buoyancy study that we did. I don't really think I could explain this perfectly over Zoom like this. I'd normally be pointing on the screen. But if you can see the mouse, you see a chine form here, which increases the volume of the hull in this upper section. You see a chine form in the back. Both of those lines are there so that as the boat flips over end, so as the bow or the nose of the boat goes down into the water, that crease
So it looks like we have technical difficulties.
Yeah, it looks like.
It's amazing so far.
Yeah, so far so good. We believe that he's reconnecting right now, so let's wait. Paula, you're muted.
Sorry, I was just saying that for everyone that is with us in the webinar or in YouTube, feel free to ask questions. You can ask questions along the talk, and at the end we will read through those questions and get them to Greg Lynn. So don't wait until the last minute to come up with questions if you have those questions in mind. Okay, I can see here a list of attendees. You can recognize some names. Hey guys.
Yeah, in the bottom of your screen, you will see the chat and the Q&A interface. You can use that. He will be back, don't worry.
Yeah. So what can we share in the meantime? We have elections this year, so don't forget to vote. We have 5 spots, 6 candidates. So you can vote until tonight, I believe, right?
Yes, and on Friday, we have a new bylaws we have been working on. Why? Because we had a structure that was never revisited in 25 years. Now, after 25 years, we believe it's time to update our internal structure. So we will submit that for your consideration. And here is he again. You're back. You're muted.
Yeah, so sorry about that. I
No
think
worries,
I've
no
learned a
worries.
lesson not to stop my videos in the middle of the presentation. I won't do that again.
Okay. Noted. Okay, let's continue.
All right.
Right.
So, everything good with the screen again?
Yes.
Okay, so at any rate, what you see now is that same form on a giant CNC mill being shaped in foam as a mold on the left. And then on the right, you see those curved chines that I was pointing out on the animation. And this is how the boat was manufactured, was with a robotically controlled mill that would carve the form, and then manually the carbon was laid up. Then here you get a view of the boat from the front, and you can see how thin the volume is at the front of the boat. And then as it moves up to the deck, you see how it gets fatter and fatter. And that's what you would call reserve buoyancy. So at the times when the boat is going to go nose down and risk flipping over, that extra volume comes into play to create buoyancy. And you see it on the 2 hulls on the left and right side as well. And I have a video that shows how those chines operate. So you can see how the boat is forcing down in the water. And as it pushes down, those shapes that I showed you are allowing it to stay level and stay buoyant. So all of that would have only been possible to design using that finite element analysis, you know, which gives us insight into how
Yeah, got it. He did it again.
We're doing it by chapters. Guys,
Yeah. Yeah, be patient. At least we know there is something about the video, and we know he will be back, right? So let's wait. More news in between.
So we have the final General Assembly tomorrow at 2:30 p.m. Eastern Time, 4:30 p.m. for Brazil. And it's very important that you attend, because we, as Marcelo mentioned, we have some new regulations that we would like for you to vote on, and we need some, you know, audience to do that. So please do that. And after that, we are planning a virtual social event to get to talk and get to know each other. So if you are still, willing to be connected to the computer on a Friday afternoon, it would be great to see your faces there and, wrap up the conference together.
Yeah, we also can inform that in our website, you will find 2 new buttons. One for them is to download the proceedings. I'm not so sure if it is ready yet. The second one is the book of our 25 years that is collecting testimonials, pictures, surveys that are representing our history in the past, the last 25 years. Okay, video again. You're mute.
Let me see if I just, can you see the screen now?
Yes, we can see the
Yes.
screen.
Mhm.
Okay, I think I'll try not being full screen and see if that helps. So the next thing I thought I'd show, if the first work was designed using animation tools, and the next thing I worked on was using simulated physics, meaning simulated flow and buoyancy. About 10 years ago, maybe less, 8 years ago, I was asked to design the physical presence of a digital delivery company. The company is called Curbside. It was since purchased by Rakuten, but it was, if not the first, one of the first phone-based tools where you could shop on your phone and then pick up goods at actual locations. So unlike Amazon, where you shopped on your phone and had things delivered, Curbside would record the inventory of an entire shopping mall or a Target or a CVS, and you could buy the product, as you'll see here. A picker would get the order, go inside the store, pick your product, and then bring it out to this pickup location where a car would drive up and the picker would bring it out to the car. So this is shown at a shopping mall in Glendale, California. What's important about it is that the landmark, the kind of Curbside pavilion, had in the top of the mast a very high frequency Bluetooth antenna and Wi-Fi, and it would be able to detect when you were within a kilometer of the location. Once you got within a few hundred meters, it would turn on the Bluetooth on your phone, and they could predict exactly when you would drive up. So the average time of a transaction was somewhere around 13 seconds on average. And so this was a kind of a marker and a piece of technology and a little piece of architecture, which was at the intersection of the digital and physical exchange of physical and digital commerce. And in thinking about this, I learned a lot about how you literally connect an app with a building. In this case, the building doesn't move, but all of the geolocating and positioning within a mapped world was all happening between a physical structure and an app. So a couple of years before, with Christian Moeller, we had entered the competition for the London Olympics, and Christian and I designed this moving pavilion, which was a carbon fiber dome. The proposal was for a carbon fiber dome that was rotated on a ring, and that ring was lifted up and down by 3 5-axis robot arms. And so I went back to that idea of a building that moved, and for the Interior Festival in Kortrijk, designed this tiny house that would be able to roll through 3 positions. So you'd be able to occupy 3 surfaces of the house, and it would also be able to spin so you could change orientation. And everything you see in yellow was a simple little robot that we designed to be able to move that domestic shell. And, here you see at Kortrijk, kind of what we built. This all, again, it's a carbon fiber shell at 1/5 the size of the actual proposal. And everything you see on the base was the robot with the 3 motors, which would move it through all of its rotations. And here you see the different sections. So a dining table and a couch in a living space, rotated here with the bathroom and the kitchen. And if you see what was the table up here is now gimbaled. So everything always stays level and appears and disappears. So the top of this surface is a table and the bottom of it is a light. And then you can see it roll over for sleeping. And again, the robot at the base that moves it. So the first movement test we did was just putting it on a 5-axis robot and studying how the furniture would rotate and spin on the interior. You'll see the way all these pieces of furniture stay level all the time. And then here you'll see an app that we built to control that movement instead. So that was an app that we did that you could just download and immediately put the robot through all of those rotations, as well as having some preset positions that you could set it to. And we wrote a very simple little piece of code that would control 2 of these motors and 2 axes so that anybody could interact with the model. This is a 1/25th scale model. That's a 1/25th scale model that's now actually at SF MoMA. So this connection of, app to controller to machine was a next step in thinking about how physical things could move. Soon, I think because of this project, actually, I was approached by Nike to help them think about an intelligent piece of furniture, which could be controlled by an app. And here you see a photograph of LeBron James about to dunk a basketball. And the task for this chair was to give an athlete a competitive advantage by augmenting them with what we called a microclimate. So we designed 2 generations of chair for Nike called the microclimate chairs. And what they were there to do is before a game, when LeBron James warms up, he's, warmed up and ready to play. During the time between the warm up and when they tip the ball, it's several minutes. During those several minutes, he cools down. And frankly, he's not able to do this for 2 or 3 minutes into the first half of the game, and then 2 or 3 minutes into the second half of the game. So our job was to make a climate that would keep him warm and flexible and ready to play, so that for the first 2 minutes of a game, LeBron James would be able to do this, while all the other players that didn't have the microclimate chair would be at a disadvantage. And the design of this microclimate was to give an athlete a higher performance. And so here you can see a photograph of the first generation of the chair using a FLIR heat camera. And you can see that different regions of the chair is at different temperature. And that's because we embedded this network of heating pads and a network of Peltier chips. And the Peltier chips will either heat or cool on one side, depending on what electrical current you put through them. So we could heat and cool areas of the chair selectively, so that we could keep certain muscle groups hot and take other areas and keep people cool. As well, we have an air channel that flows around the entire chair to blow cool air. And in the second generation, you'll see we have more technology than that. So we got NBA athletes and we tested them in different forms of the chair, trying to get as much of their body surface in contact with the chair as possible. And got the feedback from the pro athletes on which positions they'd be comfortable in while they were on the bench or while they were waiting for the game to start. And so then here's the second generation of microclimate chair. You can see the patches of heating as well as the Peltiers. We built simple capacitive touch interfaces, so the athlete can selectively heat and cool the chair themselves. We also put in cooling for the bottles that they have for, to stay hydrated, and also scales that would weigh how much fluid they were consuming while they were in the chair, and a scale to weigh how much they were weighing during the game. So we knew if they were losing too much moisture or not, and how hydrated they were staying. Okay, and then, the whole thing was put in a Flyknit wrap on the top face. And then those are on the back face, you can see those are machined aluminum heat sinks to keep them cool. And there you see two of the US basketball team players trying it out, the tallest and the shortest one. So this microclimate, that entire silver base is all custom made boards and computing. It's full of wiring and technology, but all integrated into a thing which for the athlete was very simple and straightforward to use, with just 3 sliders and 1 ring for the fan. So for me, this was the beginning. I mean, I would call this chair a robot only because it was changing climate for the person sitting in it. But it was the beginning of me thinking about how people interact with transforming robotic technology. So that brings me to Piaggio Fast Forward. I'm one of 3 co-founders of Piaggio Fast Forward with Jeffrey Schnapp and Michele Colanino. And we started Piaggio Fast Forward to think about an appropriate technology that would increase the quality of life and the lifestyle of consumers, of people. And so for us, that means unlocking the walkability of contemporary cities. So a lot of people now are choosing where they live, not based on being in a city or a particular location to work. They're often choosing where they want to live because within a mile or less, there are good schools and shopping and parks and sports. And the ability to walk and live locally is becoming more and more of a priority. So we wanted to build robots, not that would bring you things and deliver, but robots that would help you walk in your neighborhood and do your local errands and your local shopping, carry your kids' stuff to school. So instead of driving them everywhere, you're walking. And I would just say that in the last 10 years, what's a walkable trip keeps getting shorter and shorter because we have ride hailing where you can, with your telephone, instantly call a car with some stranger to pick you up and drive you a short distance. You can use a bird scooter and you can just stand on a scooter and ride for a short distance. And most of these trips are under 3 miles. So we built these robots. They actually go for 20 miles on a charge, but they're there to help you make a decision to walk a couple of miles a day rather than sitting in the back of a car and being driven everywhere, because people are driving and riding more and walking less and less. So for us, the first design problem was not actually designing the machine. It was designing the behavior and the motion. And we have a team called our Smart Behaviors team, which observes and captures how people move with each other. And we analyze that data of how they move together and turn that captured data and analysis into design specifications for our machines. So we know how closely people like things to be to them. We know how that changes as they walk faster and slower. We know how a person walks through a door when you hold a door through them. We know all these things and turn them into algorithms and put them directly on the robot so that they're kind of good citizens, because we want our machines to be welcome on the sidewalk, and we want them to feel natural to the users and also be obvious to passersby what's going on. And so our two heroes in this, as inspiration, it is the architect Greta Schutt-Lohotzky from Austria, and she invented what's called the Frankfurt Kitchen. And Chuck Jones, the cartoonist, who invented Wile E. Coyote and the Roadrunner and Daffy Duck and all kinds of characters. And the inspiration for that from Chuck Jones is that Chuck Jones was very famous in saying his characters didn't get their persona by how they looked, but in fact, how they moved. And I'll show you some drawings of his design of the characters based on their movement profiles. And Greta Lohotzky was an observer. She built a kitchen, took a stopwatch and measured how people moved around in the kitchen. And with that study and observation, optimized the kitchen and actually made it smaller, but more functional and pleasant. So here you see on the left, Schutt-Lohotzky's kitchen that she measured originally. That's the 3.5 meter square one. And then on the right, you see how she recorded those paths and then optimized those paths of work in the kitchen to make the kitchen more comfortable. So she was a person that was doing motion studies and analysis. We do something very similar at a much higher precision with higher technology, but the same idea. Here you see a Chuck Jones sketch, which on the left, if you look at the character, there's always a curved arrow that runs through the character, or curved arrows. So you see on Elmer Fudd that he always, marches with his back bent and his hat forward. Bugs Bunny is always leaning forward, so he's kind of falling as he walks. Daffy Duck also is always falling as he walks, except that his head is always moving backwards and forwards. The little skunk, Pepe Le Pew, you see that he bounces by making these arches. So every one of these characters had a signature which had to do with how they moved. And these curvatures were the basis for that movement, much like I would have thought of a spline as a designer. So, our whole team, I gave them Chuck Jones books to read, and we all watched some of his characters. But you see that Porky Pig, his character is not what he looks like, it's how he bends and moves. Same with Foghorn Leghorn, the way he struts. In fact, Jita robots are more like Tweety Bird, the way Tweety Bird always leans forward to take off and then leans back to stop. So our first thing was designing the motion and the etiquette of how the robots move. And we do that so they're good citizens, but also so bystanders can look at one of our robots following a person and understand, oh, well, that robot looks like it's taking off to follow that person. And I can understand that that person and that robot are together. So the robot belongs to the person that it's following. So again, we started with the motion. That was the very first thing that we designed. And then after the motion came the design of the physical robot. Those design considerations I think are less important compared to the motion, but they have no corners, so they're slippery when they walk around, so you can walk through a crowd with them. They self-balance so that they can accelerate and stop faster than a person can, so that they can keep up with a person. It's one of the only robots like this that can keep up with a person only a few centimeters away from them. And then they're very clear in terms of their ergonomics about how you interact with them. They have just 2 buttons. The other thing is we want people to be thinking of technology as something that is accentuating their lifestyle. So that they have a pride of ownership. And really for us, if I think about the world I want to live in, I don't really want to sit on my couch and order a pizza and have some flying drone deliver my pizza through a window to me. I don't really want to do all my shopping on a telephone and have a robot come bring packages to a locker in front of my house. I would much rather be out in the world where I know the shopkeepers and know the people and have an active lifestyle. And so that's why we don't do robots that look like they've escaped from a warehouse or a fulfillment center. We do robots that come in lots of colors, that are elegantly designed and that people are proud of using them, like YG. So these robots are at the intersection of the digital and the physical. So not only do we have the robot to think about, but we also have the app that we use to lock and unlock it. We have the packaging that it comes in and how it drives out of its box for the first time when you meet it and sits down. And we think about the website where you go learn about it and come in contact with it. The sounds were designed by Berklee College of Music. All of these things which are digital, we try to connect with the physical experience of them. And I don't want to crash another video, but let's see if this plays okay. This one actually has sound.
That I would describe the great city of Atlanta: entrepreneurship, culture, and art. I am Dr. Lakeisha Hallman, Dr. Key. I created Support is a Verb in 2016 to create opportunities for Black businesses. I think Jita is a part of that revolutionary change. This city has become an amazing pedestrian city. Jita is the new innovative vehicle for pedestrians.
So I brought these 2 videos of 2 Jita owners in Atlanta, just because of the conference.
It's a city that does what's good for people. Any entrepreneur can come here and build a dream. My name is Blake Canterbury, and I started an organization called Verbosity. And it's just based on the simple idea that you would help your neighbor if you knew they were in need. That Atlanta has enabled the city to become much more walkable. As we get out more, Ajita is a perfect companion. When somebody asks me what Ajita is, my first response is, it's the future.
Okay, so those are just a couple of videos to give you a sense of how a Ajita robot accentuates somebody's life and also how it operates and follows them. We also have taken our following hardware, our sensor pack and our technology, and put it on other people's robots who would like to add following to them. And so this video now shows how our following, which is really what we specialize in, is knowing how people move and predicting how they're going to turn and accelerate and decelerate, as well as how they move with each other, and put that on other people's machines. So this is a proof of concept that we're industrializing right now, that we did in collaboration with Trimble and Boston Dynamics. And you can see now that instead of moving a Spot robot with a joystick, which is very complicated and unnatural, you can just touch one button and it follows you. And then once it's followed you on a path, it can then reproduce that path by itself. And we've done this both outdoors and indoors. Here you can see also that for automating tasks inside a building on a construction site, a totally untrained person can drop a point, walk, drop another point, and then we can control the machine to reproduce that path over and over again. And also, by the way, this is incredibly safe. So we can bring both efficiency and safety to workers and people that don't have training in robotics. All right. So almost at the end here. The last thing I would show, I did some work with Microsoft and Trimble on the HoloLens, where we were augmenting physical models with digital content. But what I really was excited about is a collaboration we did with Neurable, who builds a dry EKG headset, meaning that it measures your brain waves. And this is the first use of augmenting a design with data that comes from a brain-computer interface. And so here you see, this isn't what we designed, but you see the environment that Neurable was using. And it's a virtual environment, and you wear a goggled headset, and it records your eye movements as well as your brain activity. And it gives you feedback on what that brain activity is as you're looking at different things in the building. So here is a video of that. Again, not in what we designed, but what they were using. You can see that purple line is showing where the person is looking in that three-dimensional scene. And then those heat maps are the things they've looked at. And then on the right, you can see the emotional feelings associated with those things that the person is looking at. So what we did is we gave Neurable a 3D model and asked if we could have 30 people walk through our 3D model, and we measured their happiness and confusion and frustration and relaxation to see if they were understanding where to move. And what's also, by the way, you don't, you move around in these scenes just by concentrating, like there's no joystick or anything like that. So we could see where people were looking to move. So we recorded both the movement through the ground floor to the second floor to make sure that we were understanding that what we were designing was clear in terms of movement. We also had 5, I believe, different options of, no, sorry, 6 different options of windows and apertures. So you can see down here at the bottom of the screen are 6 different types of window pattern. And we measured the emotions of people as they walked through our virtual 3D model to the different apertures. I have to say that the windows that we were designing turned out to be like over 80% the windows that were producing the best electrical feedback from people as they were walking through. But it was kind of amazing to have a 3D model, and instead of making fly-through animations, get electroencephalograph data from 30 people that had moved around in the building and seeing which versions of the building they unconsciously or consciously preferred. So anyway, for me, this was similar to the computational fluid dynamics to optimize performance of a foiling trimaran. This was an EKG readout of brain activity to help optimize the design of a building. And this is an office building for a company that weaves composite fibers in Manisa, Turkey, called Medix. I won't go into the construction of the building so much because we're already at 5. But you can see these apertures and openings. The building is getting ready for construction, and you can see here one of the molds that we're using to produce those 100% composite structured cladding panels that the entire building is enclosed with. And just some renderings of the building, the roof structure, some of those different apertures we designed with Neurable. And you see in the background is the factory. So what's great is they can build these super scale components in the factory, bring them out of the factory and lift them by crane with the glazing and everything already applied right onto the building. Okay, I think that's probably good. I'm sorry about the my computer crashing, but maybe let's now open things up to questions and answers, if that's good.
Okay, thank you, Greg, for the presentation. It was great. I mean, a lot of memories and new things to discuss. We have some questions here from the audience, but first of all, I want to start with a message in the YouTube channel. Nicolás Ortiz from Chile. He is today a well-established architect. He said, beware of the blob. Thanks, Greg, for all the fun. I'm assuming he is referring to that time, right, while he was in the school. Thank you too. So we have some questions here. We have a question from Paola Sanguinetti. She's the director of the School of Architecture of Arizona State University. Yeah, and yeah, she's here in the room, and she was the keynote yesterday. So this is the question. Considering how you use computational tools in the past to design and how you are using the new set of computational tools now, she has 2 questions. What do you think is the challenge for the next generation of computational tools? That is one question. The second one is, can you expand on the way you collaborate with interdisciplinary teams as part of your design process?
Sure. Yeah, well, those are two great and related questions. So, I mean, I would say that when I was much younger, you know, let's say even before going to architecture school, I was of that generation that had a Commodore 64 computer and an Apple Plus and early IBM XT, where the best you could do was write little programs, you know, to a printer and record them on a cassette tape. Like, they had so little memory. It's, you know, less memory than your average toaster or light bulb, much less powerful than a smart light bulb. So I always was interested in digital technology. But I think the reason why was because I grew up going from physical games to video games, and first video games in an arcade, where you would put a quarter in and play a thing on a television, later to video games that were in my home. And I've seen that entertainment through screens, like the move from physical things to screens. I mean, now I see, you know, my own, you know, my family and I, you know, spending hours a day. I mean, you know, maybe the majority of our day interacting with screens. And so for me, you know, I like to build models. I like to build prototypes. I like to build environments. You know, I like materiality. And the challenge, I would say, for people now is to not resist technology and just say, well, I care about details or materials and I don't care about digital technology. I mean, I've been through that phase where all the architects said that. And I think every single one of them, and I won't name names, but all of them use computers now in different ways. So I think it isn't to oppose it, but I do think you need to find humanity in it. And for me in the 90s and 2000s, finding humanity in digital tools was more about me as a designer and my process and my signature and my formal interests. Now, I think when I look at digital tools, I'm looking to find something social, and I'm trying to find the humanity, and I'm trying to find an opportunity to make people more human using technology, because it's inevitable. I mean, you're not, you know, going to resist it, but you know, I'm really not super excited about Facebook turning their name to Meta. Like, I think the metaverse is not where, for me, the humanity is. I think the humanity is in machines that make people more human. And I think that's the challenge. I mean, for me, that's the challenge for designers now, is how do you engage the technology at a cutting edge level and not resist it, but bring some concerns of an architect to that technology. And architects are responsible for the civic realm, so they need to make things more civic, and they're responsible for comfort and happiness of environments, so they need to make people more human. So and that's a big shift. I mean, it didn't happen all at once, but when I look back over what I just showed, it's a shift from you know, formal language and performance to humanity and being social. Now, what that means in terms of who I collaborate with, I'm not sure. I just always like being the dumbest person in the room. I mean, my desire in life is to be the person with smarter people around me. And so I just always, whenever I get interested in something, I try my hardest to be with the smartest people about the topic. And that's not necessarily why people get into architecture. You know, a lot of architects like to be the smartest person in the room, and I think that's very dangerous.
Probably. We have another question from Gonzalo Castro. I think I can allow him to talk because he's a attendee. Yeah, there's Gonzalo. Gonzalo, are you there? You're muted. Yeah, there's Gonzalo.
Can you hear me?
Yeah, Gonzalo is
Hey,
the
Gonzalo.
vice president of Sigradi.
Thank you very much for your presentation and for your work. I started to follow your work with Animated Form in 1999, and you were one of the pioneers in the digital, and you then documented this phase with the Canadian Center for Architecture. And as you explained well in your lecture, first you developed static form with animated tools. Then you, in a way, you shaped these tools for this effect because they were not there yet. And then also in simulation tools. And after that, you start moving buildings. And now you have friendly robots. So this is what you told us. I also remember you used to refer to the computer as a pet.
Yeah.
Use it as a pet. So what I wanted to know is related also with the previous question, but I would like to know how the use of computer has changed. You already told us that your concern is different, but what I wanted to know is more about the process itself. Do you use with your teams more algorithms? Are they different? Do you use algorithms for happiness, for example? I don't know.
Yeah. No. I mean, absolutely. I'm very proud of that computer as a pet thing because for me, technology. I mean, now it's tough to call a thing a computer, but for me, the technology has its own logic. The way like a dog is a dog or, a cat is a cat. I mean, they're not people. So I'm always resistant to personify a computer as an artist or a designer but I do think that you're capable of interacting with them on a very emotional and on a very emotional level. So for me, the computer isn't just a tool. Like I think that's really under explaining the power of a computer is it's a tool. It is definitely much more than a tool, but it's not something that you should personify or you're going to misunderstand it. It's a different kind of animal than a human animal. So, for me, with the robots, with the friendly robots, we don't try to make them like your friend. It's really not supposed to replace a person. We hope that you make friends because you have one, and you certainly meet a lot of people when you walk around with one, but it's not a replacement for a human. And it's the same thing back in the 90s. Everybody was saying, well, the computer is going to replace you as a designer. And I was always just saying, no, it's not a tool. It's more than a tool, but it's also not a person. Like you can never trust it as a person. It doesn't have that quality. So I guess I've always had that same feeling about technologies, that it should be more than a pencil. I mean, there's something more vital about them, but it's a big mistake to try to humanize them as like personas and think about your robot friend or something. I mean, I hope you say the robots are friendly just because they don't want to kill you or whatever the dystopian version of a robot is. They don't want to take over. But they move like a person, they behave like a person, just so they don't get in the way, but they're definitely not a replacement for a person. And we also don't replace workers. I mean, our robots help or augment people. They don't do 100% of a job.
Maybe I didn't explain. Do you design the interaction with the robots? Because that will be another contribution.
Yeah. Yeah. So our smart behaviors team is, it's always composed of at least one architect, because it's important that they know the built environment. And then it's usually composed with someone who's a biologist or a researcher, But yeah, in the end, we dimension and draw things that look an awful lot like plans and sections even, and turn those into algorithms for control of the machines. And everybody on that team is a designer. So they're not necessarily trained roboticists. None of them are trained roboticists, they're designers.
I believe Paula has a question. Paula?
I do. Is there any other questions online? Just following up with Gonzalo, for me, the same book, Animated 1999. I was in Chile at the time, second year in my architecture studies, and I couldn't really never go back to the building as the architecture, you know, like all the movements that you always talked about, and you show right now in the presentation that they, you know, you keep like this path of movements through, you know, the animation, the simulation, the cartoons, and now eye tracking, right? I'm just wondering two things. You mentioned at the beginning that at some point people ask you why architecture didn't actually move, and I agree, but I would like to hear a little bit more if you can expand on that. One question. And the other question is about these feelings, because I see here that, you know, everyone is trying to do analytics, data analytics, machine learning about objects, right? And that's easier because they are static. They do have all the physics formulas already defined, right? It took decades to do that, but it's done. But happiness and, you know, experience, all of that is ill-defined. And we are working on that. And I'm sure we'll get there at some point, but we are not there yet. So if you can expand on those two areas, I appreciate it.
Okay. Well, on the first one, I think, you know, I'll be the first to admit I was just wrong. So I felt very much like I was excited about the use of animation and simulation. And I have to say, I did resent someone who knew nothing about the technology saying the appropriate thing to do is have moving buildings. And so I just felt like, okay, here's a person who knows nothing about what I'm doing, but who's telling me everything I'm doing is wrong and that what I should do is build robot buildings. And so I just, instead of being more generous and saying, sure, parts of the building should move, like windows and doors move, like lots of things move in a building, maybe I should think about movement. I had this response, which was an aggressive response to say, no, architecture is about statics. And so I honestly regret taking that position in animate form. And the description of the boat, you know, lots of things on a boat move. I never should have used that example. I mean, I really do feel like it was a quick response and the wrong response. And that it is interesting to think about all the things in a building that move. Like the whole building doesn't have to move, but lots of stuff moves. And it's kind of exciting to look at that. Like, you know, here at Piaggio Fast Forward, we spent like a year just looking at doors. And it's kind of magic how two people go through a door together. It's like ballet. And we learned more about doors. I mean, I've probably drawn tens or hundreds of thousands of doors in my life and never understood what actually happens when people walk through a door. So focusing on motion in buildings, I think, is super interesting. So I was just wrong about that. But like with the doors, you really can make algorithms for things you think are not quantifiable. Like, you know, everybody, certain, you know, there's 4 kinds of doors in terms of swinging in and out and right and left. You know, everybody goes through the same way. And if you just sit there and watch them for like a year, you find out, and record them, you find out there's actually an algorithm there. And it has to do with our bodies and, you know, how we see and move through space and the door. And it's a very cultural thing. So I also know when we did the Korean church, I think the second time I met with the clients, I said, you know, I'm not a Presbyterian. Like, I'm not, you know, I don't share your religious beliefs. Is that going to be a problem? And they said, no, we want somebody objective. And I said, oh, well, because I think to make a good church, you know, there are some objective things. And the response of the Reverend was upset. He said, I don't want a modern style church. I don't want a cathedral style church. I don't want a Scandinavian style church. He gave me a list of all the styles he didn't want. And I said, no, an algorithm isn't a style. But I said, for instance, the light in a church should always come from behind you. So you never see the source of the light. So it feels like magical illumination. And, you know, that the altar should always be focusing on the altar, so that everybody is, you know, sharing the same view. And we just went through things to make a good church. And you could almost call those things algorithms. So, you know, I do think that there are certain things. I mean, happiness is a big emotion, but I do think there are things that are algorithmic rather than stylistic or even just straight up spatial, that architects could learn about, and also help other people that don't have our skills think about what the spaces are they design.
Yeah, thank you. I appreciate that. Actually, my line of research is spatial temporal modeling. So yeah.
Yep.
We have a question here from Daniel Mateus. He says, fascinating presentation. The robot house and the guitar robots open new ways of interaction between humans and the built environment. Do you think that the design of that type of interaction, for example, the interaction between people and a building, can enrich the human experience of a building?
Well, yeah, yes, but I think even more so, people are spending less time focusing on the built environment and more time on virtual environments. I mean, no matter, you know, people are spending more time on screens. Like if you take the time they spend on their phones, they're spending an enormous amount of time on screens. You know, architects are really trained with values to always think of the civic and the community, you know, first. So even though you want to make a client happy, you're kind of always thinking of more about the public realm on every project. So that's very different than a game designer, or very different than a person working in a factory or a warehouse, you know, designing robotic systems. So having an architect in a team and bringing architectural concerns, and I don't just mean like the ability to 3D model, but, you know, the ability to think about what it's like to experience a space. It's a good skill. It's a very applicable skill for the world. Like there's more room for people trained in architecture now than ever before, but it may not just be designing buildings.
Thank you. We have another question. I have a question from Pedro Sosa, professor at Universidad de Chile, Santiago, former president as well. It's a very straightforward question. It's considering your beginning, for example, that chart, right? That kind of line of design. And what you're doing right now, robots, could you elaborate or attempt to elaborate a contemporary definition of what architecture is?
Well, I mean, we're still, you know, the things I skipped were kind of the current projects we're doing that are just building projects that I'm excited about and thought I would put in a lecture, but they actually had nothing to do with the whole trajectory of technology. Yeah, I mean, I'm not involved in it. but I do think that the way buildings get delivered, meaning from the writing the brief to designing the building, to supervising its construction, to building it and being the builder, it is going to change dramatically. I mean, people have tried and failed to make all that vertical, the same way agriculture is vertical and mining is vertical. There's a desire to make the design and construction of the built environment vertical. And it will for sure happen, and it's going to change the role of the architect very, very significantly. So I have to say I'm not that much involved in it. On the board of advisors of a couple of companies working on that problem. But I couldn't give a lot of advice other than it's going to happen. It's not a question of if, it's a question of when. So it's probably good to be thinking about it, especially if you're a young person. It's good to be thinking about that whole thing. But yeah, I would say that I made a decision to never do another competition, just because I think they're not to ask people to work for. So instead, I spent time investing in relationships with clients. And frankly, the last 3 builds I've done, I've been a business partner in one way or another with everybody doing those buildings. Let me be there to help you write the brief. So, I was asked to design an engine factory for my partners at Piaggio, and told them, I'm happy to design an engine factory, but you're going to put it in the middle of a big open space where you could invite your customers into your factory to experience what's amazing about what you do. And that engine plant turned into a museum and showroom and cafe and visitor center and hotel and restaurant. And it became like a little tiny motorcycle city. So, for me, architecture is much more interesting when you're involved in writing the brief, as well as being involved in how it gets built. And I think that's going to become more and more common, that the architect is going to be part of a larger delivery system that's a very big company that's going to design, engineer, procure, supervise, and build the built environment. And it won't just be people that make drawings and give them to somebody else to build. So that's inevitable. And it's frightening. I mean, it's because there's a lot of architects that you won't be needed. I mean, same as with the computer, you don't need buildings full of people drawing plans anymore. So you're going to have fewer and fewer architecture jobs, but there's going to be a lot of other kind of jobs.
Okay, we have another question. People is, very enthusiastic. It's from David Torreblanca from Colombia. So what is the role of the experimentation in your projects? David is let me introduce David. He is an active member of the community. He's an industrial designer. He is teaching in Colombia in the School of Design. That question is coming from somebody that is working on biological inspired design, is teaching several courses, right? Is an educator, is a researcher, is a designer.
Yep.
What is David?
Well, if I try to associate experiment with risk, and I would say that I always like there to be some risk in everything I do. It's no fun if there's no risk. So I would say that what characterizes most things is not so much experimentation, but risk, which means, a likelihood of failure. So, and I've always been interested in that. I would say that term, and David, I really don't mean to put it in a wrong light, but when I was teaching at Columbia's Graduate School of Architecture and Planning, there was a lot of experimental engagement with technology that came with, so whether it was Lisanne Couture and Hani Rashid, texture mapping and moving images on forms, or whether it was Stan Allen looking at urbanism and urban analysis, using digital technology. There was experimental approach, but there was also some intuition. And I would say after 5 or 6 years, everything just turned into making messes. And everybody said, I'm experimenting. And you would just look at this mess and you would say, this is not like what a scientist would call an experiment. This is maybe like what an artist might call an experiment. But so for me, I always like a little bit of science or engineering close by if I'm doing something experimental. Like I want to know a little bit, like, not that I have a hypothesis, I would say I would have more of an intuition, but for me, it's more about just a risk. Like, let's try this thing, which could either be very successful or a real disaster, and then let's just try to pilot it from disaster to showing you something new. But I don't really have a hypothesis, but I'm also very aware that I don't want to be like doing an art project where I just make a thing and then try to read something out of it. But for me, it's maybe the biggest question. I mean, honestly, like, what's an experiment? I think anyone involved in new technology needs to ask themselves that question over and over again and never use that term lightly. Because when somebody uses the term experiment lightly, I get scared.
Yeah, thank you. I have a question too. It's it's a little bit of story. It's about becoming or an early adopter of the people that is wired to be an early adopter of anything, right? I remember at that time in the school, we were divided. I mean, we had some followers and not followers, let's put it that way. Yep. Why? Because some group of students, some group of young professors were embracing technology, and that created a sort of tension, an internal tension in the organization. And I'm assuming that it's not just our organization at that time, and it's occurring right now in many organizations. So is machine learning going to replace the design? Like is it the parametric analysis, reducing all the fun on all the intuition is right? So what is the creativity? So what is your perspective about, or your comment for those early adopters that are, for some reason, they're always on the spot? I mean, it looks like everybody is kind of challenging them, but at the same time, they are challenging everybody, but there always happen that are a minority, right?
Yep.
So what you have to comment about that strange cultural behavior of our community?
Well, like I would want to, say something addressing the early adopters more than the naysayers. So just because I care about the early adopters more than the naysayers, because the naysayers are going to be fine, actually. It's the early adopters that take the big risks. So in my experience, I listened to the naysayers, and it made me comfortable. So when everybody said, oh, nobody's going to really use computers for design, I actually believed them. And I remember vividly, I don't know whatever happened to this person, but I remember there were a bunch of us doing stuff and everybody said, nobody's ever going to adopt this. It's got no future. And then we saw a magazine featuring Peter Pran, who was an architect in, I believe, Minneapolis at the time. And he had all these buildings with these complex, like non-rationalized surfaces that he'd already built. And a lot of us, like, you know, Jesse Reiser, Danica Umamoto, we were scared. We're like, whoa, here's a corporate firm, like a firm building hospitals and stuff, that's doing what we're doing and getting it built already. And then, you know, the next thing we knew, like KPF and, you know, Cone Pedersen Fox, Skidmore, Owings and Merrill, all these firms in New York were starting to pick up what we were doing. And, you know, I just realized, don't ever listen to the naysayers. Like, you don't have time to sit and work this stuff out. You have to get involved and make it happen. Otherwise, you'll always be doing the work for other people. So, you know, it was a hard lesson to learn. I probably didn't learn it until I was like 50 years old, but the naysayers can make people too comfortable, and they can just get too comfortable with their own thing. And actually, the minute somebody tells you that they don't think something's going to happen, or that, you know, is machine learning going to take over design? It's like, well, it will your design. Like, it may not. All the people that are doing machine learning in architecture, they're going to have a great time being designers. But since you're standing here asking me that question, I can already tell, like, you're like a dead man walking, you know? So I don't worry so much about the naysayers, except I feel sorry for them. But the early adopters, they need to move faster.
Okay, we can. No, great final words.
Okay.
Final remarks. What can I say?
Right.
You should drop the mic right now. And
No, I mean, I'm being really serious about it. I would hear that stuff and think, oh, I have time, rather than hear that stuff and say, okay, that's a really good sign this is happening now. You know. Anyway.
Okay. Thank you, Greg.
Paula and Marcelo and Gonzalo, I've been seeing your faces, and thank you so much for the great questions. I have to say, these are probably the best questions I've ever had after a talk, and a talk that didn't even go smoothly. So I really appreciate it.
Well, thank you, Greg. We really
Thank you.
appreciate it. We look forward to this talk, and it's amazing. So for me, it's an honor and a pleasure, and I hope I have the chance to meet you in person sometime.
Me too. Me too. I'm sorry I'm not in Atlanta with you, but it's great to get like so many people from so many places all involved in asking questions. That's the good thing about these.
Yeah, well, the audience was not a big audience here anyway. We did small groups, you know, here in Chile, you know, but we hope this is the last year we do this, and hopefully next year we'll be in person. So.
Sounds good.
Thank you.
Thank you very, very much, Greg.
All right.
It's an
Thanks so
honor for our society. Thank you very much.
Oh, my pleasure. Thanks.
Okay. Thank you. And we continue tomorrow, so with the conference. So good night, everybody. It's been a great keynote today. Thank you, Greg.
Thanks.
Bye.